Okay, I think we can get started. Welcome back, everyone, for eUSR, the Electronic Undergraduate Statistics Research Conference 2024, the Keynote Address session. We are really delighted to have Dr. Jialiang Mao today as a keynote speaker, but I will pass on the kind of the speaker first to our student moderator, Josh Kaplan and Andy Day, who will moderate this session. They're from Colby College. So feel free to take over whenever you're ready, Josh and Andy.
Yeah, sounds good. Uh, so we're hearing from Dr. Jialiang Mao from LinkedIn and take some time for questions later, but go ahead, Dr. Mao.
Thanks, Jialiang, for the nice intro, and thanks, Josh and Andy, for coordinating. I'm super happy to be here, and thanks for having me here. So it's really feel great to come back to university or like even the university setup like this. So I've been delving into some of the talks before. I'm really glad seeing our undergrad stats data science student like doing real time, like real life research, which are deeply rooted in their life and motivated very well. So I'm happy to seeing that. And today I'm going to talk about computational advertising and data science at LinkedIn. That's a constraint. So even this is a pretty huge, ambitious topic. I know it's too big, almost way too big. I probably won't be able to cover computational advertising or data science or even LinkedIn within this 1 hour talk. But my goal is to show you some firsthand experience of myself working in the tech industry for quite some time. And actually, I want to talk a little bit about how data science look like in the industry setting, how we organize the data science teams to support the work we do, and how the works we actually do here are different from the work we do in graduate school or undergrad statistical courses. So with that, a very brief overview of what am I going to talk about today. So I will first describe, like just set up some context, LinkedIn and LinkedIn ads, basically just some high level overview of computational ads and also the business problems we need to solve. Then I will move a little bit to talk about a somewhat weird topic, which I don't think has been covered very well in some of the similar talks I've been into. I will talk the role and journey of data science team. More specifically, I will describe a little bit on how we set up the data science team from the operational and organizational perspective. The reason I talk about that is because the structure of the data science team actually changes rapidly over time, and especially over the past 5 years. And that actually reflects the change in requirement and expectations of data scientists in the tech industry. So I want to use this as an angle to talk a little bit about how to prepare yourself into the tech career and how I think the requirements are changing compared to maybe the time when I first joined the industry. Then, if we do have time, I will probably give you 1 or 2 examples, like solving real problems in the industry. And I will use experimentation as an example because that's very probably one of the most commonly discussed topic in the academia setting when people talk about applying statistics in the tech industry. And I will describe a little bit on how that problem is different from what we seen it in the in the academia angle. And given time, I will probably provide a few examples. So with that, very quick intro. So I started my career in statistics and data science from Duke University. I know almost nothing about statistics before that. So basically, all my statistical background has coming from Duke. So that's why I'm a pretty Bayesian person, as you might imagine. And my research focus was on Bayesian and parametric modeling. I did a lot of tree-based modeling and a lot of applications of in the in the bio setting, specifically microbiome sequencing data. And after that, I joined LinkedIn directly. So I had a relatively linear career growth path um, after I joined the industry. Most of my time has been spending with LinkedIn within the ads industry, actually. But I did serve different teams. So I will talk about those teams very briefly throughout the talk. So with that, hopefully everyone here has heard of LinkedIn or has tried to use it. And it's I, and by the way, I'm just gonna use this time to give an ads, so to serve an ads here. So because I work in the ads industry, so if you're ever gonna consider applying for grad school, consider Duke. And if you ever want to work in the industry, give LinkedIn a try. So it's a really interesting place. You can search for jobs and you can even work for us. So we're hiring, by the way. And just very briefly, the goal of LinkedIn is to create economic opportunity for every member of the global workforce. So we're free for every member to use. And this is basically the member sample size that are look like very, very briefly. So we just hit the 1 billion member milestone earlier this year. And you can see the members are pretty evenly split, like spread across the whole world. And this is effectively the sample size we're going to work with for a lot of the data science problems we have here. And you might think, okay, this looks pretty large. It is large compared to a lot of the, like, for example, biological applications we see in the academia setting. But if you compare LinkedIn with other tech companies like Google, Meta, we're actually like order of magnitudes smaller in terms of sample size. That actually create a lot of challenges when it comes to statistical modeling or like deep learning modeling, for example, because if we apply some of the pretty well standard models in like Google, our sample size is not big enough to support a lot of those modeling techniques. And that's a pretty interesting challenge we're actually facing, not because the sample size is too big, but actually because the sample size is too small, even under this 1 billion member setting. And just to zoom into that a little bit, we have over 1 billion members, and they are not the only entities we have in the LinkedIn network. And the other things like companies, schools, and people's skills are actually what makes the LinkedIn graph, the LinkedIn network super interesting. Because if you compare LinkedIn with, for example, Facebook, they also have way more members, right? They have way more users, but a lot of the times they are not having other entities like companies, schools, skills, especially like skills in a pretty well stated way. Because if I use LinkedIn to find a job, I have the motivation to actually put in the real information I have. So that's why, in terms of the data quality, we are arguably pretty high compared to other social networks. An important observation of this network is that it is not static. In fact, it is changing all over the time. For example, people use LinkedIn for different things. They use LinkedIn to search for jobs, which create, for example, some connections between members and companies. And they can also change their behavior. For example, they might use LinkedIn to find a job, which modifies their status. And actually, there are 6 people hired every minute on LinkedIn, which is making this graph super dynamic. And this also create a lot of opportunities for us to answer different questions, but also put challenges into how we actually model this data. And so this is all good, right? And by the way, we're offering a lot of the service for free. Then people's question might be like, how you guys make money? So there are some channels we can make money, which people might be more familiar with. For example, you can pay a monthly fee as a user to access some premium features. And companies can pay us money to get more insight into the candidates, basically to make matches for their job openings. But that's not the only way we make money. And actually, that's only a large portion, but it is not all of the story. A large portion of the LinkedIn's money is actually coming from advertising. So somewhat surprisingly, a lot of people actually don't know we're actually doing ads. So when I talk with people, like introducing myself as I'm working on LinkedIn ads, they're like, so basically you're working on nothing. Because a lot of people have never heard of LinkedIn ads. But we do serve ads in a pretty similar setting as, for example, Instagram. If you open LinkedIn app and you will see sponsored content with a promoted tag like this one. And from advertisers' perspective, why does this product make sense, right? Because you already have pretty well established ads platform like Google, Meta, some other companies too, right? A more traditional format like magazines, TVs. Why you want to do ads with LinkedIn? And the unique value we're providing to the customers, which are advertisers in this setting, is because of the unique data we have. Specifically, we have the professionals around the world. So our users are not just a random sample from the population. Instead, we're actually basically sampling a lot of the decision makers regarding business decision. For example, there are data showing like 4 out of 5 LinkedIn members can drive business decision. These are not only people who make those decisions. For example, data scientists are considered driving a lot of the business decisions because a lot of the insights we're providing will help the business owner to make a decision. And all of this unique information is what make LinkedIn very unique and what make LinkedIn advertising have a very good return on investment for advertisers. So as a data scientist, what is our job? This is to just give you an overview of the space. So there are a lot of stuff in this slide. Don't worry about that. This is basically a screenshot of the product we're providing. For example, you need to support different types of ads. You need to support ads with different objectives. For example, some ads might try to just bring attention, basically for awareness. I'm building this business, so I'm doing advertising to make people aware of my business. Some other ads might have a more deeper funnel objective. For example, there are ads before Thanksgiving to make people buy stuff. Those are more like conversion based advertise. Each one of them require a very different like tech stack. For example, ads that are optimizing for awareness probably need a pretty different strategy versus ads that are optimizing for sales. And all of them are what we call product. So basically, we are offering all this product for advertisers. And as you can see, not only objective, right? That's only one dimension we need to talk about when we need to think about when we build those things. There are other dimensions like the format of the ad. You can use a single image, you can use a video, you can even send messages to members. All of these different formats needs data science, needs machine learning, needs optimization. And that's where all the problems are coming from. And if you go even deeper under the hood, you will see like how you actually serve the ads is depending on a lot of factors. For example, how do you price those ads? How do you decide which ad to show to which member? And how do you generate report for advertisers to actually see the results? All of this comes into this pretty complex product suite. Then this is effectively the playground we have. Basically, these are the problems we're facing. And the goal of the data science team is to support all of this product and the models that supports this product as a whole. So just to give you an example, what are some of the business questions we need to answer? A pretty obvious question is like where and who should we serve as, right? So just from the product perspective, we serve ad on multiple placements or like multiple places. For example, this is my LinkedIn app, and this is the desktop web page. Basically, if you go to LinkedIn, either through your phone or your laptop, you will see multiple slots we show ads. For example, this one on desktop, we show ads on the right rail. And if you actually click on the message box, there can potentially be so-called sponsored messaging ads there. And in the feed, you will just see ads as in a pretty normal feed flow setting. But there's also other placements where we serve ads. So once advertisers decide to do business with us, because we know our members' behavior, not only on LinkedIn, but also through like those different machine learning process. For example, if you use a third-party web like New York Times, we probably can, with a high probability, predict who you are on LinkedIn. So that's how I actually can serve ads there. Basically, when I know who you are, I can decide to put my advertiser, my customer's ad on the third-party web. That's also how we serve ads. Basically, we can serve both on-site ads and off-site ads, and these are where the data is coming from. So, and to better understand what the data science problem we need to solve, we need to better understand the LinkedIn's role in this huge ads marketplace, because ads business is huge, and as a relatively small player, what is our role? So actually, LinkedIn serves three different types of roles. First one is we provide ad supply, which makes us a so-called supply-side platform. By ad supply, I simply mean like ad slot users are creating. For example, whenever you open the LinkedIn web page, you will create a lot of opportunities for people to show ads. And that inventory is what LinkedIn is providing. So that's the first role. We're providing ads inventory. We're providing opportunities for people to show ads. The second role is whenever there's people who want to do ads business with us, we will sign contract with them. They will put money with us for us to sell ads for them. And for those cases, we are representing the demand side of the ads business. By ad demand, that simply means like companies, advertisers who want to do ad with us. So we can take this demand to either serve ad on our own platform or bid for a slot in other platforms, which makes us effectively an ads marketplace. So these are three roles LinkedIn is playing, and basically both as the supply side provider and as the demand side provider, as well as a marketplace like organizer. So this is the example of the advertiser side business we're providing. Basically, as a member, you probably will never use this web page, but we actually build a whole suite of product for advertisers to put their demand with us and to serve as a demand side platform. So just this is a very high level overview of the relation we need to worry about. We have three types of entities, mostly LinkedIn, our members, and advertisers. As you might imagine, a lot of the questions we need to answer are regarding how these three different parties play with each other, right? So if I'm serving too many ads, advertisers might be happy, but members are not happy. If we don't serve enough ads, members probably will be happy, but advertisers are not happy and we're not making money. And if we make both advertisers and members happy, do we still make money? That's the problem we need to face. And as a data science, we are actually sitting in the intersection of a lot of these key decisions. And as a matter of fact, a lot of our job is actually to help the company make the right trade-off. Because, for example, if I want to make money in the short term, I can just easily increase the price of ads, or I can simply show more ads. But what is the cost? Of course, if you look at the in-year revenue, for example, I can probably boost that in a very easy way just by like increasing the ad slot. But what does that mean for the business in the longer term? That's what data science team needs to worry about. Just to give you an example of the real business problem we need to face, and also describe a little bit of how we actually sell ad. There are two ways you can buy ads, buy the ads product at LinkedIn. The first way is guaranteed delivery. It's basically I will sell chunk of ads impressions before the delivery happen. This is very similar to the traditional way of buying ad slot, like on a magazine, on TV, or on, for example, Times Square. Basically, you are paying money for showing an ad on the front page for a while, and the price is determined based on the contract, and that's determined before any ad is shown. The question is how to set the price and how much slot should we sell through this. For example, I can sell all my LinkedIn slot through this channel, but what does that mean? The second channel is which is also more standard, is basically I'm selling every single ad in a real-time bidding environment. So whenever a member visit LinkedIn, whenever there is an ad slot, multiple advertisers will try to bid for this slot. And we are basically placing an ad based on the auction result and also charge advertisers based on the auction result. There's a whole bunch of theories behind that. And this is currently the standard for computational advertising. And this is the under the hood, this is the engine driving the Google's business and driving Meta's business. Actually, what is interesting is that when LinkedIn started the ads business, real-time bidding has already become a standard way of building this market. So that's why the real-time bidding was actually built first at LinkedIn. And only very recently, people start to think about, okay, shall we offer the other type of buying opportunities for customers? Shall we offer the traditional way of selling ads? Basically, shall we enable guaranteed display on the LinkedIn platform? The business question as data science we're facing is, shall we make this decision? Because building this product is not hard. Everything is actually pretty well established. We can basically just establish an team to build this product. But shall we do that? The reason we want to do that is because if you sell this guaranteed display ad, you can probably sell them at a higher price because they are premium slot. You might want to sell them more to make more money and to make sure advertisers have the exposure they want. But what is the cost? The cost is, are this additional dollar amount we're making, are these really incremental? And what is the cost from the engineering perspective? What is cost from the long-term business perspective? That's all the questions we need to answer. So remember this example because that's one of the examples I might use later to illustrate some of the points I make later. So this is the playground. This is our playground, our data, our business problems. And next, I will talk a little bit about data science in the organization and the data science teams. basically, what does data science do here? Data science are effectively connecting data to decisions through the insights we're providing. Basically, this is how I define the job function we have here. Basically, leverage data to create actionable insights that can facilitate business decisions. So there are three key components. The first one is data. You need to actually define your data. You need to define the metrics you want to track. You need to define when and where to track them, how to store them, how to maintain them, how to make sure they are correct. All of these questions. And you need to not only just provide raw data, you need to generate insights in some way to make them digestible by human, by the system, or by some machine learning models. And this is really usually covering, for example, reporting. Am I doing good? Am I doing like not am I not doing good? And if not, what are the gaps? Those are the insights people usually need. And also the more important thing here we need to talk about in a business setting is what decisions or what actions can this insight actually be driving? I can easily produce, for example, 1,000 of data sets and using those 1,000 data sets to create 1,000 of dashboard and plots. But what does that actually mean? What am I telling? For example, if we present any of this insight to our machine learning partners, what do we want them to do? Whenever we are showing our leadership a dashboard, what is the insight and what is the decision we try to make them make? So that's the key problem we're facing. I'm highlighting data and decisions, and the reason is because in the pretty standard data science or statistics curricular, we are mostly focusing on this path. Basically, we will be prepared with data, or I know recently we are emphasizing a little more on data collection, but basically, a lot of the questions statistics students need to face stop at the insight generation. Basically, you might feed a model, you might feed multiple models, and usually if you write a paper, you need to generate some insights. If you write a like application paper specifically, usually people are pretty happy if you stop at the insight stage. But in the business setup, insight, I would argue it doesn't mean much unless you can tie that to a real business decision. For example, if I'm showing my business is growing, that is nice. But what our requirement or what's the leadership's like expectation really are is basically tell me what to do next. So after showing me this data, does that mean I can grow my business 2 times in the next year? And if not, where are the gaps and where are the opportunities? Those decisions are really what makes DS a key job function nowadays. It's not like before where people are very happy by just seeing those numbers, seeing those graphs. And I will explain a little bit on later on why that is no longer the case. Basically, we need to support product decisions like, do I want to make this new product happen? Do I want to build a whole new delivery system? And sometimes I also need to make like AI modeling decisions. Shall I change this model from a simple regression model to a deep learning model? And what kind of model structure needs to be considering? And a lot of that doesn't have a pretty clear boundary with, for example, machine learning engineers. And I will also explain a little bit more on how we split the job function. Um, so, what kind of data science we have? Actually, if you look at the job description, there might be different tracks here at LinkedIn. And this is a pretty standard way people are defined. I don't want to use the word define or just want to restrain people into these tracks, but that's usually how the job functions are different from different data scientists. The first one is this more classic traditional business analytics, which just support the key business decisions globally, more like those financial decisions, especially, for example, for the LinkedIn case, we are part of the Microsoft company. So we need to make sure the quarterly revenue goals are hit, and we need to know how the business is trending. That is the classic business analytics job function. They will usually use analytic tools like Tableau, Excel, and some of them might even write some SQL queries or feed very lightweight modelings like an OLS regression type of model and time series model or like just simple visualizations. And their goal is to usually very close to the high level business. Basically, where is this business trending and what are some of the very top line problems? A more classic data scientist role is what we call product data science at LinkedIn. This is the data scientists who work very closely with business partners, but to support not the global business as a whole, but a more specific product. For example, if I'm want to build a new product called this guaranteed delivery, I might need to generate a lot of insights to help me build the system to help me make decisions. And that is where I need a product data scientist. This data scientist require a little more structured capability, and the tasks are also pretty well standard. For example, I need to do opportunity sizing, and to evaluate whether I should build this product to start with. And after I build this product, I need a measurement design. I need to run A/B tests to see whether this product is working, and I need to even define what does working mean. And after I build this product and launch it, I need to do monitoring, I need to do reporting, and a lot of this maintenance and iterations. For this more classic product data science, usually modeling work is pretty heavy. So this is their daily job. So they will need to run a lot of statistical modeling tasks, and they will need to run a lot of A/B testings. Another type of role is what we call research scientists, research data scientists, or scientists in different companies. And these are data scientists who work on a little more abstraction of the problems. Instead of working on a very specific business problem, they are working on common problems that are faced by multiple data science teams or like machine learning engineers. The problems I might want to run a new type of model to tackle this specific format of the data, but I don't have readily available statistical tools. For example, XGBoost, like all these machine learning models, might not work for my data. Then what should I do? If this data challenge is pretty common in the industry or in the company, then some research data scientists will need to come and build new models. The key difference between this track and the previous track is the previous track is focusing a lot more on application, while the research data scientist is focusing on a lot more on the how part. So basically, you can view this as building the fundamental pieces of the solution, while the track one data scientist is taking those solutions to solve real world problems. And there's also another track which becomes more popular recently, which is the data engineer. The popularity of large language model is really making this track important, but those are more engineering focused rather than data science focused. So that I would not talk a lot about that. But basically, their job is to build data foundation, to make all the data available and make them in a good quality, prepare them in some sense for other data science to digest. So a key question is, okay, we have all of these roles, right? How we put them together? So at first you might think, okay, why should I worry about this, right? Because if I'm applying for a job, however you put me in, I'm just doing my job. The reason I want to talk about the structure of the data science team is because, as I mentioned before, it actually reflects the changes of expectations for data science teams. So this is how we currently structured it as data science team at LinkedIn. So we basically have 4 teams. And these teams are somewhat horizontally structured within the ads organization. The first team is a more classic product DS team, and the goal is to support new product initiatives. For example, their job would be, if I have a new thing I want to build, like this guaranteed ad, there would be a dedicated data scientist from this team to work with stakeholders like engineers, product managers to build this product from end to end. And there's a second team called the Tech Foundation team, which is more composed of data engineers. Their goal is to build data foundations and productivity tools for data science and then data science engineers. And there's another team which are pretty specific for the ads case. This team is what we call measurement and experimentation team. This team develops new measurement solutions, basically A/B testing strategies, A/B testing designs for ads use cases. These are both for the internal cases where we want to compare 2 models, and also for the advertisers who want to basically make any measurement decisions on LinkedIn. The reason we built this team is because measurement is a specifically challenging topic in the ad setting. I will probably talk a little bit about that later. And we have this 4th team, which we call System and Marketplace Data Science team. The goal of this new team is to provide a comprehensive understanding of the marketplace and the system. So you might wonder, like, how we end up with this structure, right? Because it doesn't seem very natural. Product DS and Tech Foundation maybe, but for the other 2 teams, it seems a little random, and it is. So, and it is not always the case. So around 10 years ago, when we started kind of doing the ads business, this was actually the structure. Basically, there are multiple data science team organized based on the product they need to support. For example, I might have one product DS team to support ads pricing. There might be another data science team to support customer-facing products, and there may be a third team support the third-party ad serving. Basically, if you think about this, you can view this as a clustering problem of your problem space. So basically, if you have different product, you can mentally run a clustering model and split your team based on that. So what happens when a new product needs to be built? Basically, I will just try to cluster that new data point into these two different teams. And this makes sense when the business is small and new, because maybe there are not that many products you need to support, but it suddenly becomes like not scalable enough because the product space is expanding and this team structure just doesn't allow people to work on long-term and deep enough problems. And you might have the question like, where are the track 2 and track 3 teams in this structure? To be honest, when this was all started, there were only track 1 data science folks because the business was new. There were a lot of low-hanging fruit. So you don't actually need to go very deep into those research questions to solve the business problems. Put it in another way, the product was new, the system was new, so you don't need to optimize that too much to meet your business goals. You can basically just keep shipping new product so that money will come. But that no longer becomes the case after you hit that first growing period. So that's happened around 5 years ago at LinkedIn. Basically, that's when there's no longer this generic, very healthy growth in terms of the business. That's when we need to really do some serious optimizations to make sure the product is optimizing for people's value so that they will put additional money with us, to make sure that we are delivering good enough member experience so they will keep visiting back. And that's why a lot of those deeper and more like fundamental research questions come from. And that's where we actually started building a horizontal research data science team to start hire those track 2 folks. And around 5 to 10 years ago, this was the structure at LinkedIn. Basically, we have different vertical teams, that's what we call them, like ads data science team, jobs data science team, or like a flagship data science team, which is covering the core experience of LinkedIn app. Basically, each data science team will be vertically structured by a different product DS team. And on top of that, we have a centralized research data science team to cover those deeper and harder questions. For example, there might be an experimentation data science team, which is trying to build experimentation solutions for all the vertical DS teams. Similarly, there might be a team focused on forecasting, another focus on like computational social science, because we have a lot of computational social science questions. And more recently, there are privacy challenges. So there's a horizontal team focusing on all the privacy challenges faced by different vertical teams. This worked very well for a while, but what's the problem with this organization? The problem is as the vertical business grow larger, their needs become very different. Just taking experimentation as an example, before everyone can probably use the same design. All the 3 vertical DS teams can use roughly the same design until a point where they realize their data assumptions are very different. The populations need to face are very different. The type of challenges in the data are very different, which calls for very different designs. That's when this horizontal structure becomes inefficient. And that's where around 2 to 3 years ago, we actually disbanded this horizontal research data science team and spread those track 2 DS folks into these vertical teams more directly. And that's what brings us here. Basically, before we have all track 1 teams to start, and then we have horizontal track 2 team, and now we have the horizontal track 2 team disbanded, but track 2 folks split almost evenly across these different vertical teams. Why we make this change? So I want to use this very little analogy. Basically, if you think about this 2-dimensional space as the problem space you need to cover, x-axis means the product, y-axis means the job function DS need to fulfill. In the past, it's like we are vertically organizing the teams. Now we are horizontally organizing the teams. So why we do that? You can view this similar from this Riemann integral versus Lebesgue integral analogy. Basically, you're covering the same space, but this organizational structure change allow us to solve problems that wasn't previously solvable, that allow us to solve more challenging, longer term problems from the data science perspective. Just to give you an example, so we have this whole new team called Marketplace DS team, basically try to support the constant decision needs from the organization. But you might ask, like, on all the other data science teams try to make decisions too? Yes. So what's the difference here, right? You have all these decisions you need to make. But what's the difference? The difference is now we realize there are a lot of decisions that needs to have this long-term focus and needs to consider multiple teams, multiple areas in a more global way. And I will explain that in a minute. And another challenge we're facing is when we make a lot of these decisions, we need to face this super challenging system and marketplace. So what does that even mean? I'll skip this, but this is just to give an example of all the decisions we need to make. Basically, this is our system. So you can see this is a very oversimplified view of the system, but it's already getting very complex. Basically, there are different system components that try to answer different questions. For example, when we start this ads auction, and who should we allow to join the auction, who should be the winner, like how you serve ads, a lot of these different things, right? So the problem is all these different components are internally handled by different product manager, by different AI teams. So when they make decisions, they are usually making short-term decisions which will make their own module look good, not necessarily making the whole business good. And these decisions are almost always new, like local. But in some cases, these local decisions doesn't lead us to a global optima. For example, when there's a top-down requirement to increase ads revenue, some team might just, for example, some team in the ad auction module might just increase ads price. And when they do that, the other modules, okay, they might find, for example, why the pricing becomes so high because I didn't change anything. So a different team might try to lower that price. And as a matter of poor communication or coordination, this can lead the system into a very weird situation. That's when some global optimization needs to happen. And that's the value provided by this team. Another complexity is because we're operating in this pretty complex market. Because as market is very dynamic and we're not the only players, there are big players and there are micro changes like COVID that suddenly will change the business. And a lot of the cases, because of this marketplace setting, a lot of the classic data science assumptions we're making, like all these independence assumptions, doesn't really hold. And that does bring a lot of challenges regarding how we measure and how we actually do the modeling. That's why we created this centralized data science team to tackle these decision-making challenges as a whole. So just to summarize a little bit, what are some of the new expectations for us and new requirements for data scientists under this rapidly changing landscape? The first one is we really need scalability, because when we create this new org structure, what we really hope to solve is this scalability issue. Basically, we don't want every data science to support every new product we need to build. The idea is whenever we can build a decentralized structure, we can basically solve this problem once and once for all. For example, instead of building very case-by-case specific solutions, we want to build platforms. We want to build tools for other data science, for the non-data science business owners to actually solve the problems themselves. The second requirement is system thinking. So instead of just focusing on the machine learning statistics problems assigned to you, now we need to actually develop a very deep understanding of the engineering system. And the reason for that is because first, you need to be familiar with all the new tools, like how to get your data, how to prepare your data, how to store your modeling results. And another reason is to make right decisions actually require you to understand better how the system function, how the system components are connecting to each other. The third one is this organizational structure, and this is actually what we find, what a lot of data scientists find very challenging, is how to actually sell the stuff you're building. Because if you're thinking a little bit about the scalability solutions we're building, basically we're building our own product. So you need to sell that to other data scientists, to your partners, to the business owners, right? So what is really needed is a product mindset. Basically, we need a very deep understanding of the problem we need to solve, and we need to really understand what users are needed. So the final one is accountability, which is also missed by many data scientists, because whenever we do this, we need to embrace a sense of ownership. Basically, we need to take greater responsibility for guiding the organization to make right decisions. A lot of the cases, the organizations are tend to make easier decisions. For example, they might just increase ads pricing to get more revenue. But as data scientists, we need to tell them whether this is right or wrong. If it's wrong, what's the trade-off they're actually making? We need to serve as an objective function to make sure the core business is making the right decisions. The right decision not only for the business itself, but for the members and users, whoever using the platform. So yeah, that's probably a lot to talk about. Just to give you one very quick example of how we do things slightly differently in the industry. So I will use A/B testing as an example because this is probably familiar by many of folks. This is a classic illustration of A/B testing. So basically, whenever I have a new product, whenever I have a new experience, I launch it to maybe half of the population, I split my population into A and B, and apply two different experience to them. This is the classic illustration of A/B testing, which is probably right and very intuitive for people to grasp the core concept. And we do test basically every time. Whenever we launch a new thing, we will do an A/B test. So this is the classic view of A/B testing, but it's actually not accurate. The reason is we sort of, to simplify stuff, always teach student A/B testing in this pretty standard two-stage setting where we first do an experiment, and based on the experimentation result, we will make a decision. So what is not accurate here? Actually, what is happening is in the real setup, we are actually doing experiment in an iterative way. So instead of just doing this split and test once, we're actually doing this many, many times. So for example, instead of just splitting the traffic to 50-50, we will start very small. We will start, for example, 1%, and we will test the new experience there to make sure everything works. And then the treatment percentage will slowly be increasing to a point where we can accurately measure the impact. And this stage can repeat multiple times and can repeat over a course of like days, weeks, or even months until a business decision can be made confidently. And what does this mean for us? This means actually the data setting is very different from a one-time split because, for example, you need to now worry about time. And for each member, for each user, you might have multiple iterations. That's what we call them. You might have data over multiple iterations, which give you a lot of information you can use to make the decision. For example, with this iterative process, you can test how your treatment effect change over time. You can test how the treatment effect interact with different user groups with different, like at different time points. This creates a lot of different challenges versus the classic A/B testing. That's one key difference we need to deal with. To summarize a little bit, we run experimentation for a lot of reasons, and that's a key function DS needs to support because running experimentations can serve a lot of purpose. It can help the business to understand the value. It can augment decision making. And the second one is actually always ignored when we teach A/B testing in, for example, some statistical courses. So this is like an overview. This iterative process actually can serve different purpose at different stages. The first stage is risk mitigation. By doing experimentations, the first value it's providing is actually it allow the organization to mitigate the risk, because instead of just ramping the new feature to all the customers, we're ramping it to a small percentage of users. And then through this iterative process, we're actually getting direct feedback from users about the product. And then it allows us to measure the effect of launching these new things. So this is how we actually do A/B testing in the industry. And I will probably stop here. Below are some of the examples. If I can share the slides, feel free to take a look. These are very specific examples of the experimentation challenges we face in the industry, and especially in the ad setting. So I actually make the slides a little compact and dense than I need to. The reason is I want to actually emphasize an interesting point where this talk structure is very similar to how we actually do product in the industry setting. Basically, you start talking a lot, learning a lot about the business context, and that probably take a lot of time. And then there are other challenges you need to face. For example, in this talk, I talk a lot about organizational structure. That's a key challenge we need to face. Basically, you need to talk with people, you need to understand the problem, not only the technical problem. And when you get to a point where you can actually talk about technical details, like the third part of the talk today, you probably will run out of time. And that's the trade-off, and that's the key challenge data science needs to face. A lot of context building, a lot of non-technical challenges, and some challenging problems from the technical perspective. So I'll probably stop here. Feel free to take a look at examples. And by the way, I didn't intend to cover all of them. I just want to use them as an illustration. And thanks again. So do feel free to reach out to me anytime. And if you have any questions about any of these things I'm talking about, or about how to build up a career more generally in the tech industry, let me know, and we can chat. Thanks.
Awesome. Okay, so we're gonna open up to Q&A for the next like 10 minutes. So if you have any questions, you can put those in the Q&A box and you can answer those. Might take a second. All right, seeing a couple. Jialiang, can you see these, or should I read them?
Let me stop sharing and maybe I can see them. Yeah, now I can see them. How do you define a good ad? Is that the first one?
Mhm.
Okay, cool. So that's a great question, and that's actually a core task we need to solve. So you can define different ads in different ways, right? The simplest and the most standard way to define good is by users' response. For example, if users are clicking them, then we define them as good. And that's the core. That's the core definition. Basically, we will measure the quality of the ad by the relevance and by the by members' behavior. But as you might see, this is not very accurate in terms of the goodness of the ads, because that in some sense are confounding two factors: the quality of the ad and the relevance. So that's why there are some pre-screening of the ads. For example, just purely based on the image, based on the video, there will be some quality scores. Some of them are actually labeled by human. So we mainly, to summarize, we mainly use click-through rate to measure the goodness of an ad, and we complement that by other quality measures, like just purely based on screening. And that's pretty standard. And I believe Google have a huge team on ads quality, and that's a key topic in the industry.
Okay, and then there's one more in there right now. What is a typical interview like for a position such as in your team?
So that's a good question. And do reach out to me if you want to learn a little more about how these interviews might look like. So there are a few different modules. So it's all modularized. Basically, there will be a statistical module, there will be a more applied data science module, and there can sometimes be a coding module. The coding module is, depending on the track you're applying for, can either be focusing on data preparation, like SQL type of coding, or more Python R type of coding. And there will, for our job roles, we usually also depend on the team, have a wildcard module to test some specific requirement we have. For example, for the experimentation team, we might test you for causal inference, and another team might do a more deeper machine learning module. And there, of course, are communication modules. You will talk with hiring managers and to learn a little bit about each other.
Hello.
Hello.
Are we being broadcast right now? All right. But the panel doesn't start for 8 more minutes?
Yeah, hi Joe. We are still in the keynote session, and Dr. Mao here is answering the questions from his earlier keynote talk. So,
So my
uh,
question about us
it's
being broadcast is no.
it's live.
People can hear what I'm saying?
Yeah, exactly. Yeah, so gonna need you. We'll ask you to wait for a few minutes, and then yeah, is that okay? All right, thanks.
So we got another question. Someone from Google said ad quality is not always measurable. So they hire people to review ads. So it's like people doing them, which you
Yeah,
mentioned.
exactly. So as I said, if you use something like click-through rate, you will face problems like clickbait, right? That's why a lot of this purely quality-based measure needs to happen before even serving the ads. And a lot of them here is also based on like human labeling and basically people scoring them. And if you think about this a little deeper, this is really the challenge people are facing when evaluating a lot of this, even those large language model applications, because there's no label and defining the label is actually pretty subjective. So, and there's a lot of noise because usually we hire third party like contractors to score those ads, and those does create a lot of challenges. But there's currently no better way to score those ads based on their quality. And there are works here, for example, to use those labels to train large language models, like or like just deep learning models, transformers to tackle those tasks. But those are mostly ongoing, and that seems to be a trend. Again, you have this classic garbage in, garbage out situation where if your label is wrong, then everything else is probably not reliable.
Someone in the Q&A asked, how are LLMs influencing your workload and the
That's very
workflow?
interesting. So, to be fair, we're using those tools a lot. And part of that is because we are a Microsoft company. So we have access to a lot of those tools at a pretty early stage. So, for example, we use GitHub Copilot for code reviews quite extensively. And internally, we have been building tools to basically replace a lot of the ad hoc data queries, like all the questions you can think of regarding how should I write a SQL query to pull some data, like what's the average dollar amount each US member is generating, questions like this, we are automating them with large language models. And workload wise is a lot of this so-called ad hoc or like those pretty shallow requirement, which doesn't require actual human insight, has been we try to replace those with large language model powered tools. And a lot of the team's focus has been to building those tools and evaluating those tools. And that's a very nice question. I kind of like didn't touch those large language model cases just intentionally because that's a whole lot of new story. And I still don't have a very good observation at this point because there are a lot of things happening in the past 2 years and we still haven't converged into a state like stable enough stage. Another question I see, since the iterative selection process can take a long time, how do you make business decisions while keeping advertisers happy? That's a very interesting question. So usually this iterative process can happen very fast. So actually, a lot of the cases we are doing this iterative cycle within a month. And so usually advertisers won't notice this many cases, because we're launching features and you kind of like you don't want them to know you're launching something, right? That's interference effectively. So, and we are building, there are a lot of like early stopping rules we're adding. For example, if you see very bad thing, probably you don't want to continue the process. You want to stop them early. And there are also cases where if you find out something is really good, you can launch them faster. But of course, there's a lot of like you need to deal with all the speaking issue. You need to deal with all the dependencies this is bringing in.
Okay, just a couple more minutes if we have some last questions. I might ask one, I guess, if no one has any. You talked about like the skills that people on the different teams use and like the general organization, but what are the more like day-to-day work and statistical skills that you're implementing for
That's
yourself?
a interesting question. So personally, I'm considered as more like a research data science role. So our job is more focusing on the longer term. For example, very specific problems I'm solving right now is how do you measure the ads related effect in the longer term? Because a lot of the A/B testings we run here, for example, are for maybe a month at most. But usually, if you're really looking for long-term business goals like yearly, how the members' behavior change over time, that require a lot of waiting. And how do you accelerate that process? How do you use early stage, short-term signals to forecast those longer-term business goals? That's one thing. And another one is we have different system components. So how do you make sure like all the machine learning models are coordinating correctively or like in the optimal way so that we don't do something like in the opposite directions. And the second project is not a typical data science project. The first one was a very standard statistical problem. I can write down the formulation just as like a pretty standard modeling process. The second one is more like an engineering plus data science kind of role, but that's becoming more and more as a requirement nowadays.
Awesome. Well, if there's no more questions, I guess, thank you. And yeah, pass it back
Thanks.
to Xiaoyang.
All right, and let's thank our keynote speaker, Dr. Jialiang Mao again, and also thank Josh and Andy for your moderating. I think we have like about 1 minute before we move on to our next session, which is a graduate school panel. Yeah, so